Let us illustrate the concept of convergence in case of any iterative method. Particularly we are interested in case of NR method, which is known as Newton-Raphson method, for finding a root of a nonlinear equation fx equal to 0. Let us write it as convergence condition or convergence criteria, we may say, of finding a root for a nonlinear equation fx equal to 0. First of all, let us illustrate that this form of equation may easily be converted as this x equal to phi x, which is urgently required to illustrate the fixed point iteration method. As far as this Newton-Raphson method is concerned, the formula of it may be written as the formula of Newton-Raphson method may be written as, this is an iterative method, and you may write the formula as alpha n plus 1 is equal to alpha n minus f of alpha n by f prime alpha n. Okay? So if we express this as a phi x, this equation, phi x is nothing but x minus fx by f prime x. So we may put it as x equal to phi x. As an example, let us take this equation x e to the power x equal to 1 plus cos x. So we can easily write it as x 2 cos square x by 2 e to the power minus x, which is comparable with this form. So to find the convergence criteria or convergence condition for a fixed point iteration method, we would like to frame the scheme of operation like this. Let us assume that x0 is the initial approximation of the root. So whenever we put x0 in place of x equal to phi x is the equation for which we find the root. We would like to find the root. Let us represent it as, to avoid confusion, let us write this as zeta equal to phi zeta for the root itself. So whenever we have a zeta for which we have a fixed point, that means the function phi gives us the value of zeta, then it is the fixed point for that function, isn't it so? And we have expressed this form to represent any nonlinear equation fx equal to 0. Okay? And we look for this root. x0 is our first approximation. So we have x1 as phi x0. And since this is an iterative method, we have this and this and so on, giving phi xn minus 1 equal to xn. Just see this. This is an iterative method. X0 is the initial approximation or the first approximation of the root. So x0 is not the root, and whenever we put x0 in place of x, we have x1, and then we place x1 in place of x, we get x2. And at this point, we assume that the iterative method converges. What does it mean? That we have found the root for which we have j equal to phi j. So if we put phi xn here, it will give us xn only, not xn plus 1. So that is why it converges here. That is the basic concept. Okay. Now a simple bit of mean value theorem. If we apply it, we can easily see that what is phi x1 minus phi x0, sorry, x0. This is nothing but x2 minus x1. Isn't it so? And if we employ mean value theorem, this is nothing but phi prime xi1 or zeta1, whatever you say. Since we have written zeta here, let us keep it zeta1. So this zeta1 lies within x1 and x0. Similarly, what is x3 minus x2? Since x3 is phi x2 and x2 is phi x1, this turns out to be phi x2 minus phi x1, isn't it so? And this in turn, employing again mean value theorem, within x1 x2 we have x2 minus x1 into phi prime zeta 2, where zeta 1 lies in the interval x0 x1 and zeta 2 lies in the interval x1 x2. We are interested in the interval x0 to xn minus 1, and we assume that all these phi prime zeta j mod value is less than n. We assume this. We can easily assume it. Isn't it so? Mod value of phi prime zeta j in all these intervals throughout from x0 to xn, we have this. And then if we put this back, we have, what is x2 minus x1? This is x1 minus x0 phi prime j1. Isn't it so? And what is x3 minus x2? It is x2 minus x1 into phi prime j2. And similarly, if we keep on doing this, in the last case we have phi xn minus 2 minus phi xn minus 1. xn minus 1 is nothing but phi of xn minus 1 minus phi of xn minus 2. Isn't it so? This is clear. And this, with this same mean value theorem, may be written as xn minus 1 minus xn minus 2 into phi prime xi n minus 1. Isn't it so? So what we have, let us write it clearly. We just remember that we have assumed this to be true, the value of let me write it clearly. We have assumed that phi prime we have assumed that phi prime zeta j mod value is less than m throughout the interval x0 to xn. Okay, and what we have is that x1 equal to phi x0, x2 equal to phi x1, x3 equal to phi x2, xn equal to phi xn minus 1, and at this point the process converges and we have the fixed point, which is the root. Now if you move on to employ mean value theorem step by step, x2 minus x1 is nothing but x1 minus x0 phi prime xi 1. Next step is x3 minus x2, which is nothing but x2 minus x1 phi prime xi 2. Isn't it so? Now what is x2 minus x1? It is nothing but x1 minus x naught into this. So this turns out to be x1 minus x naught into this, and since all these are less than m, we put an m square here, and thus going on in this way, when we reach xn minus 1, we have nothing but this. Isn't it so? M to the power n. And we can easily say that if this m is less than 1, can easily say that if this m is less than 1 throughout the interval x0 to xn, we can infer that xn converges to the root, since this is coming out to be this, and if n is less than 1 for a sufficiently large number of iteration, if this one is small, that is our first approximation is good, then we have convergence criteria fulfilled. So in case of a Newton-Raphson method, what we have the formula written as phi x equal to x minus fx by f prime x. Isn't it so? So what is phi prime x? We take the derivative of phi x, it becomes 1 minus f prime x by f prime x. When we take the derivative of fx, and then when we take the derivative of 1 upon f prime x, it becomes plus of fx by f prime x whole square into f double prime x for chain rule. Isn't it so? The derivative of 1 by f prime x is nothing but minus 1 upon f prime x whole square, and for chain rule, since we are taking the derivative with respect to x, so f prime x is to be derived with respect to x, so it is into f double prime x. Now this 1 and 1 cancels out and it comes out to be f double prime by f prime square. And since we have this condition for Newton-Raphson formula, which is nothing but this, we must have fx into f double prime x strictly less than f prime x whole square. This is the convergence criteria in case of the Newton-Raphson method. Okay, fx into f double prime x must be strictly less than f prime x whole square.